Jeff Klott with the Robert E. Mason Company. I'm the Principal Field Service Engineer.
And I'm Mitch Jones with the Robert E. Mason Company. I'm out of Charleston, South Carolina, and I'm an account manager. Today, Jeff and I are here to talk about a system that he and one of our counterparts named Ray Young came up with. So Jeff, what are we looking at? What is this?
It's an Enhanced Reliability System, ERS.
So we call it an ERS.
Right.
Okay. And what makes up an ERS?
Basically having two digital valve controllers.
Those two
digital valve controllers able to control one valve, and if you have a failure of any component in that primary system, we have a backup redundancy. We in certain installations we can have triple redundancy in the system. So it's answering a problem that industries, especially the nuclear industry, has had for years using standard pneumatic positioners. There's a number of things. Instrument air quality issues. There was a certain manufacturer that was utilized in the nuclear industry that they had very poor reliability, and that was the number one issue with the control valves in nuclear plants. When one of these goes down, one of the feedwater valves goes down, they're required by the NRC to be down for 7 days. Typically, for a reactor, it's like $1 million revenue per day.
Okay.
And so they're very interested in utilizing this technology.
So what is all this? We've got the two DVCs, but what else is going on here on this panel?
All right, these are HIM monitors. They are actually monitoring the heart signal from the instruments. And we can program the instruments and the HIM to, look for certain alert conditions. And we can send a signal back to the control room, and they can have auto switch capabilities where it switch by itself, or they can manually do it as well. And they're, watching the level control in the steam generator, and if it starts getting out in either direction, they can tell the quality of the instrument, and they need to go to the backup. They can hit a button, or we've actually got it set up in some of the plants that automatically swap over. But we got two field view instruments and isolation valves, so you can isolate each instrument totally, perform maintenance on it without shutting down the plant. So that's pretty much in a nutshell.
And then you've got two lights on the panel. What's the purpose of those?
Show the condition of each of the loops, which this is the primary controller, this is the backup controller. So the different colors indicate something else.
So if it switches, then the beacons will change colors.
That's correct.
So that's good for an operator who's making the rounds.
Exactly.
So now, Jeff, you've talked about a nuclear plant, but if you're looking at this and you're in a pulp and paper mill, or you're in a chemical plant, or some facility where you've got an application that's mission critical, and you believe that a redundant DVC application like this, or an ERS, would be something that would benefit your facility, could you apply this same type of concept?
Yes, much more compact.
So it wouldn't be as complex as this?
Right.
Okay.
Yeah, but it serves the same purpose. And, these are safety solenoid valves, so you have to use dedicated equipment and controlled. Cybersecurity is a big requirement that we have to follow. So, but what I would use like a paper mill for feedwater control or pressure reducing valves, the whole thing would fit in this cabinet.
So a much smaller footprint, but it would still give you that redundant capability so that if this mission critical valve had something went wrong with one DVC, it could be set up to automatically switch over to the other DVC, keep the process running.
Right. To do it so fast, you hardly notice any difference.
Great.
Yeah.
Well, if you'd like more information about the ERS, call us at 704-375-4464, or you can contact us on the web at www.remason.com. Thank you.